All right, let's dive right in. We're about to take a look at the very fabric of reality. And I mean a really close look. So close, in fact, that the whole thing kind of starts to unravel. You see, down at the quantum level, the universe just doesn't play by the rules we're used to. It's a massive puzzle, and it all kicks off with a really strange question about time itself.
So here's the puzzle, and it sounds like something straight out of science fiction. Can a choice you make right now actually change something that has already happened? I mean, your gut reaction, my gut reaction, everyone's gut reaction is, no way, of course not. But in the quantum world, well, that's where the answer gets incredibly weird.
And to see just how weird it gets, we need to talk about this thing. This is one of the most famously mind-bending experiments ever cooked up. It's called the delayed choice quantum eraser. And listen, this isn't just some wild idea on a blackboard. Scientists have actually done this, and the results are what completely torpedo our common sense understanding of time and reality. Okay, let's walk through the setup step by step. First, a single photon is fired at a screen with two slits in it. Simple enough. But then it hits this special crystal, which splits it into two entangled twin photons. Think of them as linked no matter what. The first twin, we'll call it the signal photon, takes a super short path right to a detector. Bam! Its journey is over in a flash. But its twin, the idler photon, gets sent on this much longer, more roundabout journey. And that's where we get to make our choice.
Now, this is the part that you have to lock in on, because it's everything. The signal photon hits its detector and gets recorded long before its twin, the idler, has even finished its long trip. The signal photon's arrival is a historical fact. It's done. It's in the past.
And here we go. This is the truly wild part. At the end of that long path, we make a choice about the idler photon. Choice number 1, we set up a detector to see which path it took. When we do that, we find that its twin, the one that hit its detector in the past, shows up as part of a simple clump, like a particle would. But choice number 2, if we use a clever setup that erases any information about which path the idler took, well, when we look back at the data from the signal photon, the one from the past, it's now part of a wave-like interference pattern. Let me say that again. A choice we make in the future dictates the pattern that was created in the past.
So, what is going on here? How is this even possible? How can poking and prodding one particle seem to reach back in time and change what its twin did? This single, bizarre result forces us to stare down some of the absolute deepest questions in all of science.
You see, this isn't just some quirky lab trick. It's what physicists call the reality problem. This one experiment basically forces us into a corner where we have to choose between some completely different and, frankly, completely bonkers versions of what our universe is actually like. And here's a really important point. The math of quantum mechanics works. It works perfectly. It predicts the outcome of this experiment with 100% accuracy. The debate isn't about whether the math is right. The huge, century-long argument is about what the math means. And that's what an interpretation is all about. It's an attempt to connect the bizarre equations to the world we actually live in.
And as the physicist N. David Merman once said, there are a lot of them. For almost 100 years, the smartest people on the planet have been arguing about this, and you know what? No one's won the argument yet.
So let's look at two of the heavyweights, the two most famous contenders that try to solve this reality puzzle. On one side, you've got the classic, the Copenhagen interpretation, and on the other, you've got the mind-bending many worlds interpretation.
And these two ideas could not be more different. The classic Copenhagen view says that reality is kind of blurry, a wave of possibilities, and it only collapses into one definite thing the second we measure it. The act of looking literally creates a single unique history. But the many worlds view says, nope, there's no collapse at all. Every single possible outcome actually happens. It just splits off into its own parallel universe. So yeah, there are infinite, equally real histories all happening at once.
Now this fundamental weirdness, this idea that reality isn't really real until something looks at it, has led some people to take a giant leap from physics into philosophy, and to ask a much more unsettling question.
Could it be that the universe seems so strange, so counterintuitive, because it isn't real in the way we think it is? I mean, what if the universe is just trying to save on processing power? You know, like a video game that only renders the details when you turn to look at them.
And this line of thinking leads us straight to the very popular simulation hypothesis.
It's exactly what it sounds like. The idea that our entire reality, everything from the Big Bang to you listening to me right now, is all just code running on some unbelievably powerful computer in some other base reality.
But, and this is a huge but, here comes the twist. The very same quantum weirdness that makes a lot of people suspect we're living in a simulation might just be the absolute strongest argument that we are not. This insight, which gets kicked around by theoretical physicists and debated in places like Reddit, points to a massive roadblock for the whole simulation idea. It's something called the computational complexity problem.
So the logic goes something like this. As we study the universe at the quantum level, it doesn't get simpler. It gets exponentially more complicated to model. Seriously, just simulating the quantum behavior of a handful of particles is a colossal job for our most powerful supercomputers. So to simulate our entire universe, down to the last quantum particle, well, that computer would have to be, by definition, bigger and more complex than the very universe it's trying to simulate. And that's a paradox. You can't fit a box inside of a smaller box.
So let's bring this all home. The totally bizarre, almost game-like rules of the quantum world, where things only snap into focus when we look at them. That's what makes the simulation idea feel so plausible.
But that exact same weirdness reveals a level of complexity so ridiculously vast that it seems to rule out the very possibility of it being simulated. It's this beautiful, ironic twist. It turns out reality might be even stranger than a simulation.
So where does that leave us? Well, the truth is, after a century of this debate, nobody has the final answer, not even close. Physicists, philosophers, they're all still arguing. The quantum reality puzzle is very much still open for business.
Which leaves us right back where we started, staring at the biggest questions of all. Is our past set in stone, or can it be rewritten from the future? Is there just one universe, or an infinite number of them branching off every second? The only thing we know for sure is that reality is far stranger and a whole lot more interesting than we ever could have imagined.